we'll continue further into the chapter of matrix for standard 10. We have already discussed what is a matrix. We have discussed the kinds of matrix. We have discussed the transpose of a matrix. We have discussed the first operation, that is addition of matrices. Now the second operation on matrices is subtraction of matrices. Subtraction of matrices is exactly the same as addition of matrices, and it is only possible if the two matrices are of the same order. If they are of the same order, then we can add them or we can subtract them. For example, I have written two matrices. One is A 5 4 2 1. This is of the order 2 into 2. We told you what is the order, number of rows into number of columns. It has got 2 rows and it has got 2 columns. Similarly for B, I have got 2 rows and 2 columns. So both matrices are of the same order. That is why subtraction is possible. Like we can add also A and B. We can subtract B from A or A from B. Let us see A minus B. A minus B. We do exactly the same as we do addition, because subtraction is also addition with an opposite sign. 5 4 2 1 is A minus 3 0 4 2. Even I can do that if you like. I can show it and make you understand this one. 5 4 2 1. I'll make it plus here. I'll make it instead of minus plus, and this minus will go inside with each term. Minus 3, 0 plus or 0 minus does not matter. Minus 4, minus 2. Now when we add these two matrices, obviously what will you get? 5 minus 3. Corresponding elements are added with the signs. 5 minus 3, 4, minus 0 or plus 0 does not matter, 2 minus 4, and 1 minus 2. So what I get is 5 minus 3 is 2, 4 minus 0 is 4, 2 minus 4 is minus 2, 1 minus 2 is minus 1. So we get A minus B as 2 4 minus 2 minus 1, and it is of the same order as the two original matrices were. A and B were of the order 2 into 2. So A minus B is also of the order 2 into 2. Now suppose I want to calculate B minus A. Suppose I want to calculate B minus A. So B minus A means first I'll write B 3 0 4 2, and then minus 5 4 2 1. If I subtract, 3 minus 5 is minus 2, 0 minus 4 will be minus 4, 4 minus 2 will be 2, and 2 minus 1 will be 1. Now you will realize that A minus B is not equal to B minus A. A minus B is not equal to B minus A, while is A plus B was equal to B plus A. And that is why we said that commutative property was followed by addition of matrices. But here A minus B is not equal to B minus A. Let's take another example and show it to you. For example, A is 5 4 3 minus 1. B is 2 1 0 4. 2 1 0 4, and C is minus 3 2 1 0, minus 3 2 1 0. Now he wants us to calculate A plus B minus C. He wants us to calculate A plus B minus C. A plus B minus C. So we will write like this. The matrix A is 5, 4, 3, minus 1 plus 2, 1, 0, 4 minus 3, 2, 1, 0. Now what we do is, we again we'll take the minus sign inside. You can do without that also, there is no issue in that, but it will be easier for you to do it that way. We will take the negative sign inside, make it plus 3, minus 2, minus 1 and 0. Five plus 2, 7 plus 3, because minus has become plus. So 5 plus 2, 7 plus 3, 10. Then I have 4 plus 1, 5. 5 minus 2, 3. Corresponding elements. 3 plus 0 is 3 and then minus 1. It is 2. Minus 1 plus 4 is 3. 3 plus 0 is 3. So this is the final value of A plus B minus C. So it contains addition as well as subtraction of matrices. And this is only possible when they are of the same order. If they are of the same order, then we can find the matrix. For example, let's take another example where we will discuss the transpose of a matrix and the matrix. We told you what a transpose of a matrix is. That if we interchange the rows and columns of a matrix, it becomes its transpose. Matrix A is given as 2, 1, 3, 2, 1, 3, and it is given as 4, minus 3, 2. 4, minus 3, 2. This is the matrix A. And the order of this matrix is number of rows into number of columns. There are 2 rows and 3 columns. So, when I will find the transpose of this matrix, I'll get A dash or AT. I'll get 2, 4, 1 minus 3 and 3, 2 as A transpose. Now it is not possible for us to add A and A plus T, AT. We cannot add or subtract. We cannot add A to transpose of the matrix because here the order is 2 into 3, but here the order is 3 into 2. So the order of the matrix A and AT are not same. Order of matrix A is not equal to order of matrix AT. Hence, addition or subtraction of A and AT is not possible. It is not possible because we told you that 2 matrices can be added or subtracted if they are of the same order. Here the order is 2 into 3. Here the order is 3 into 2. That is why the matrices cannot be added or subtracted. The next thing which I have to discuss in this topic is additive identity. Additive identity. What is additive identity? What is additive identity? Additive identity in matrix will be that if we add something to the matrix and matrix remains unchanged, then that quantity which is added to the matrix is called additive identity. For example, I have a matrix A. For example, it is A, B, C and D. This is a matrix of the order 2 into 2. It's a journal matrix I have taken. And if I add a null matrix to it, I can add a null matrix also of the same order. Suppose B is 0, 0, 0, 0. This has to be of the same order. Then only we can add A and B. Then only we can add A and B. So A plus B will be A plus 0, B plus 0, C plus 0 and D plus 0. If I add 0 to A, it remains the same. That means A, it becomes B, it becomes C, it becomes D. That means when I added 0 to it, when I added the null matrix to it, the matrix remained the same as A. The matrix remained A only. A is A, B, C, D, and if I added 0, 0, 0, 0 to it, the final answer was the same as matrix A. So B is called the additive identity. B is called additive identity. And additive identity in case of addition of matrix is the null matrix. B is a null matrix or zero matrix where we realize that all the elements of the matrix are 0, 0. Now let us see additive inverse. What is additive inverse? Let me take the same example, that is A is A, B, C, D, and let me take A to be minus A, minus B, minus C and minus D. If I add A and B, suppose I add A and B, I will get A minus A, B minus B, C minus C, D minus D. It will be what? 0, 0, 0, 0. Or if I find out B plus A, it will be also 0, 0, 0, 0. So if it happens that on addition of two matrices, we get the answer as 0, as a null matrix, not 0, null matrix. It is a null matrix. If the answer comes out to be a null matrix, then we say that B is the additive identity for A, or A is the additive identity for B, because additive inverse. Identity was a null matrix. It is the inverse, additive inverse, because by adding B to A, I get the answer to be a null matrix. So B is the additive inverse of A and A is the additive inverse of B. Okay, thank you.